Welcome back, friends. In today's session we are going to discuss about the vapor composition, and we will move to some of the few examples about the Raoult's law. Now if you remember, in the previous session we said that according to Raoult's law, if we have pressure of A which is equal to mole fraction of A, then partial pressure of pure A, and then pressure of B which is equal to mole fraction of B, then partial pressure of pure B. We said pressure total will be is equal to pressure of A plus pressure of B. This is called the vapor pressure of the solution, vapor pressure of the solution. Now, in this concept of vapor composition, we want to know to how much extent the vapor will be formed by component A, and to how much extent the vapor will be formed by component B. As we know, in the vapor phase, we will have pressure of A, which is equal to PA, and pressure of B, which is equal to PB, making pressure total. So now, kwenye liquid tulikuwa nasema ni mole fraction. Mole fraction of A ilikuwa sana number of moles of A divided by number of moles of B, then plus number of moles of A. Hii ni kwenye nini? Kwenye liquid phase. Kwenye liquid phase. But if we are moving now to the gaseous phase, this changes. Haiwi tena mole fraction. Tunahitaji vapor composition. Tunaiandika kama XA, then tunaput 1 dash. This is the first vapor composition. How do we get this first vapor composition now? This is a very important concept for you to know. How do we get this first vapor composition? To get this one, we must take partial pressure of A divided by partial pressure of A plus partial pressure of B. So this is how we can get what we are calling the vapor composition. Vapor composition. So for example, this is the first vapor composition. Then in the second vapor or third vapor, tutafanya hivyo kwa calculate kwanza partial pressure. So kwa mfano, hii vapor composition tutaitumia kwenye kukalkulate nini? Second vapor. Manake hii pressure ni ya kwenye first vapor. Then in the second vapor, that means in the second vapor, pressure of A in the second vapor, will be equal to vapor composition of A, then times pure pressure of A. So the pure pressure of A remains there, but here the dimension changes. Raoult's law is still applied as usual. So the vapor composition expresses the percentage or mole fraction of each component of a ideal solution in the vapor phase. Vapor composition is obtained at the ratio of partial vapor pressure of components of total vapor pressure collected above ideal solution. So vapor composition, we are saying vapor composition of A is given as the partial pressure of A divided by total partial pressure for ideal solution. So vapor composition of A, naweka kama mole fraction pale naweka dash is equal to pressure of A divided by pressure total, and vapor pressure of B, vapor composition of B inakuwa kama hivyo. So tukija kwenye partial vapor pressure of B, then this is how we can express the mole fraction, some mole fraction now vapor composition. Now let's move to some of the few calculated examples regarding the Raoult's law. And let's see how the questions they can be solved. Now for the sake of our first question here, the question says calculate the vapor pressure of a solution containing. We are given mass of heptane. Data given mass of heptane, ambayo mass of heptane tumepewa 50 gram, have then and 38 gram of octane. So mass of octane will be equal to 38 grams. Temperature ndio hiyo hapo, but temperature is not so much important. Vapor pressure of pure liquid at 30. Vapor pressure of pure liquid is at 30. Hiyo hapo, and for heptane and hiyo for octane. So vapor pressure P0 for heptane will be equal to 473 pascals, and P0 for octane will be equal to 140 pascals of octane. Calculate also the vapor composition of A and B. Kwanza calculate vapor pressure of solution. Have pili calculate vapor composition. So the question is very simple. As we know from Raoult's law, if we want to get the partial pressure, or if we want to get vapor pressure of the solution, that means it is P total, which is equal to pressure A plus pressure B. But remember, in order to get pressure A, we need to have the mole fraction of A, then pressure naught of A. So for the sake of here, pressure naught we have, but we don't have the mole fraction, so we can't get this dimension. How do we get mole fraction? Mole fraction of A, or mole fraction of heptane, is equal to number of moles of heptane. Number of moles of heptane divided by total number of moles. Total number of moles. So the first thing we need to do here is to calculate the number of moles. We need to record the structure of heptane. Heptane, it has 7 carbon, so C7H will be equal to 7 times 2 is equal to 14 plus 2, 16. So what will be the molar mass of this compound? It will be 7 times 12, then plus 16. Plus 16 utapata ni 100 gram. So number of moles za huyu hapa zilizokuwepo, number of moles of heptane itakuwa sana 50 divided by 100, which would be equal to 0.5 mole. Number of moles of heptane. Number of mass of octane. Octane ni C8H. H manake itakuwa ni 20. I mean, it's not 20, it is 18. So C8 20 18 hydrogen. So times plus 18, tutapata ni 114 gram per mole, molar mass hiyo. Kwa hiyo tukitafuta number of moles itakuwa sana 38 divided by 114 gram per mole. Utakuja kupata ngapi hapo? Utakuja kupata 38 gawanya kwa answer, utapata ni 0.333 mole. So kumbe tukitaka kupata pressure total of solution itakuwa sana tutachukua huyu hapa, tutachukua 0.5 divided by hapo, tukiplus tutapata 0.833 times pressure naught of huyu hapo 473, then hapo tuta plus 0.333 divided by 0.833, then times 140. Hiyo hesabu inaweza kufanywa hata mara moja tu, kama uko vizuri na calculator yako unaifanya kwa mara moja tu hiyo hesabu. 0.5 divided by 0.833 hapa na multiply by 473, then na plus 0.33 na plus 0.33 in bracket 0.33 divided by 0.833. Here hapa natakiwa niweke 0.333 divided by 0.833, then from there tuna multiply by 140, then the final answer ambayo tunapata ni pressure total is equal to 339. But we don't know the individual pressure ya huyu hapa heptane na huyu hapa octane. Kwa ni vizuri tungetafuta pressure of heptane will be equal to 0.5 divided by 0.833, then times 473, tutakuja kupata ngapi? Ni 283.9.914, then this is Pascal. Then pressure for octane itakuwa sana ngapi? 0.333 divided by 0.833, then from there tapata ngapi? Hiyo hapo tuta multiply by 140 tutapata ni 55.96. Kwa hiyo all in all, kitu ambacho nakizungumza hapa ni kwamba hizi ni pascals. Tumeshatafuta pressure of the solution, tumpata 339, na hata wao hapa katika kusolve hizi ukitaka hizi notes utazitafuta kule kipage up, utazitafuta hizi notes, ila katika kusolve walikuja kupata walikuja kupata jibu la mwisho. Mimi sijapita kwenye hizo procedure zote, nimeenda tu moja kwa moja mpata 340. Mimi jibu langu lilikuwa ni 339 kwa sababu ya kufanya calculation ambayo ni ya ujumla, lakini ukienda step by step unapata 340. Now what is required also is the vapor composition. Now vapor composition, tumeshapata pressure hapa, tumeshapata pressure huyu hapa, huyu na huyu. So vapor composition, for example, vapor composition of heptane will be equal to pressure of heptane ambayo ni 283.914 pascals divided by pressure total ambayo tulipata 339 for our case. So tutapata vapor composition of heptane 283 then 0.914 divided by 339. So tukidivide hapo tutapata for example 0.838 for the case of heptane. Kwa wao kujibu walimpata 0.836. Kwa nini wampata 0.836? Kwa sababu tulidifa kidogo kwenye total pressure. Wao walikuja kupata ni 340.466. Why nimekuambia? Kwa sababu sisi tulienda calculation ambazo wao mpata 0.33, si tumeandika 0.333. So hii inaenda ku affect the final answer. This is just one among the example in the Raoult's law. In the next session we discuss the second and other examples in the Raoult's law before we are going to discuss about the other parts. Thank you. Don't forget to subscribe the channel and to share the link for this video.